Big D.
Big D.
We're going to be big data, big D. We're going to make a big impression on the United States, and Silicon Valley is going to take notice of us, especially
Absolutely.
after.
I want to take that message back.
Especially after this workshop, the work that you see come out of this workshop, they're going to notice us.
Absolutely. I think they're on the Twitter already.
So Sanjay's here to put us on the map.
Let's do it.
So yeah, I can back that up with data. So that I tweeted about 7 days ago. Dallas, actually North Texas, was like the number 4, the most number of big data jobs that were being advertised.
I keep that on my radar. So I think we had the great speakers over the morning. I think we learned a lot of foundation, a lot of use cases that we can do, what we can do, what we cannot do, how it's done, what kind of data science we can apply. I think it's very interesting. So now, I may speak a little faster. Please come back to me and say, hey, slow down a little bit. So I'm happy to do that. So basically, we all know there's a lot of data sitting in Excel sheet, MS Access, Oracle database, or Postgres. It's my experience. And who heard about Mumps database? Still using it?
I'm not, but it's out there.
Oh, okay. So once I never heard it because I used to work in a financial company and they bought this product. They're like, what is this? Then I told my friends, hey, we do Mumps database. And he said, stay away from this disease. Right? So interesting. Point is, in an organization, we have data sitting across a variety of platforms that we need to bring together. Right? And now I think big data, Hadoop, has given an opportunity to bring all the data together and make some meaning out of it. So let's delve into some stuff that I think we should take a look at before we really start. Okay, go do some Hadoop work, or do some pig scripting or some Hive scripting. So basically, in any company, I see this one a lot. Right? People don't know. I work with a cloud team. Cloud team, they just have to, their focus is to build a cloud platform, get the device connected, where I work in IoT space. That's all they do. Then ask, where's the data? I ask him. They never think about the data. End of the day. My point is, every time you develop a method, you develop an application in a Jira environment or an Agile environment, always think about the data. What the value you get out of it every time, right? So you see, you have to evangelize the data across the organization. Then you can build a data platform. You just cannot go and build a POC and take it to your boss. I don't want to do this because I don't see any value. So you do POC, but you evangelize from the top. So then you get funding, you get more value out of it. A lot of POCs fail, 4 months project, they wind up, they forget it, they go back to Oracle database. So it happens a lot. So that's why you see adaptation is very low. People know big data, adaptation is very low. So I think this is one of the important things, right? If you don't make decisions, you generate it, right? And you have to do the second part to get some meaning out of it. You've got to torture it more, so it speaks more, right? And I took it from CIA, twisted it a little. So I think that's good enough to start with. And this is a very interesting. I think people may know who said this statement. Who made this statement? Anybody can guess? Right? So, or politicians are aware of big data back then, but they don't know really how to name it. Right? So, I really like this guy. He's a visionary. But if you look at it, right? So, I think we can answer a lot with the data and the framework that we have. A lot of KNOW change, right? So this is one thing. So we come across a large amount of data here. So why do we need this huge framework? What do you want to do with it? And what do you get out of it at any time, right? So if I go to the next click here, there's only so much value. To get this value, you need to work on this bigger rectangle every time. So basically, we have a framework which makes it happen, and you take a huge amount of data and get a little actionable data out of it. So if you want to get a bigger rectangle in the middle, imagine the amount of data that you need to process. So amount of resources that you need to have to process the data. Right? So I think this is some insight into why we're going down the path. Right? So here, this is the actual map where I work right now, taken a year ago. These are the dots on a map by zip code. This is actual data. If you take a dump from firewall in a data center and build this one, basically each dot is a zip level and shows maybe number of devices connected. So can anyone guess how does this map fit into different organizations in the company? Take a marketing, engineering, operations, sales. Can anyone guess? How do you? What do you guess out of this? What makes out of this map?
AT&T service locations.
They're device connected. They're device connected.
I just joking.
Yes. Anyone take a wild guess? How does it help you? What do you infer from this map?
Correlation to population.
Population.
That's a good guess. But right now I don't have a population layer on this one. So as it is a raw map with the dots.
Concentration of devices. And
Absolutely right. That's one point. What other things you can see? The marketing guy said, I don't see many people buying here, I need to sell more. Right? Right? And the service industry of the same company, hey, I need to put more service centers over here because I have more density of devices here. So people can get to me very fast. Right? And ops guys looks at it, hey, I need more data center resources here because I have more devices connected from this side. Maybe I can do geolocation based and other stuff, Anycast, all those things. Right? So this is one simple example. And this is just a dump from firewall. Maybe I had like command K rows that I could read a small SQL script, pull up the Tableau, and got this one. This is all it is, the device connected in the east and west. Now you see, there are more technical savvy people on the edges in the middle, on this side. They want to connect products. They want to connect their garage, their washer dryer to the internet, right? So now we can sell more. This is one simple use case that I do every day in business, right? So MapReduce is not new. We know Lisp, Smalltalk, it was there, but it was never evolved because the constraint of hardware, networking, and stuff like that, right? So these are not new actually. We have more. What's new is these two things. We tend to underappreciate the advances made in hardware, memory, chip speed, the Moore's law. Because of that, we were able to do this framework. Otherwise, it won't evolve. So we underappreciate our i7 micro laptops or hardwares, right? So I think we should attribute that. Can anyone guess what is this?
IBM on it.
You want to ask what that is? That looks like, is that a drum?
It's a hard drive.
Yeah.
It's a disk drive.
Isn't that a drum?
That's a great picture.
5
Right over
Yeah.
1,000 kilograms.
I love it. So 5 MB hard drive being loaded to the airplane. Right.
Drum. But it's a drum, isn't it? Drum-based system?
I think so, but I don't know that part. I don't want to know. I don't want to know, right? So basically, the point is where we are at right now. If flash drive, maybe how many times bigger than that, or how many flash drives you can fit in that one? You think other way around. Right? So if I fit 1 GB flash drives in that box, probably I have enough resource for the data center to run a data center. So point is, I think we go back and see why we're talking about data, why you have to process data. I think we attribute to this innovation, how things were there now. And imagine 5 MB, probably what they're transporting, NSA files or CIA files, what they could hold in that one. Impressive. So now we come back to our traditional hard disk, right? So we have 100 billion records. We have the equation right here, right? So if you want to use just one particular spinning disk and do some data analysis, and how much time it would take to do? Right. 2.7 hours a scan read. Right. So now we need distributed data set. So what we assume in a distributed system, right? Hardware can be reliable, right? Machines have an identity, and this is the most important thing. Data must remain local all the time. Data locality is the main mantra. That's why we can do MapReduce, we can do Spark, and other things. Without the data locality, you cannot process the way we're doing this. So we can do data locality because we have enough RAM on a simple laptop than a server 10 years ago, right? So basically, let's start some workshop. So any questions about this? Anything I talked about? I just browsed through because we talked a lot, so I want to take a different perspective on this one, right? So
Got one question. You mentioned locality. For companies that have a lot of their corporate data on the mainframe, would you say run Hadoop on Z-Linux on the mainframe?
no, no.
What would you
ETL
recommend?
the data into Hadoop infrastructure, do your work. ETL the data,
Uh-huh. Okay.
move the data, right? So Hadoop is a complementary solution. I'm not saying go and just dump all your Oracle rack. You paid millions of dollars and you're doing your transaction system on it. No, Hadoop can be a complementary. Or you have an existing EDW, Enterprise Data Warehouse, and you want to do some analytics on it. Then you have pipeline from EDW into Hadoop infrastructure, do analytics, get aggregates, take the aggregates back into your transaction system that you can make some meaning out of it, right? So Hadoop is a complementary. So never think of, hey, how can I get rid of Oracle all the time? They do two different things, right? You have banking system, I think you keep Oracle, right? So you want to do analytics, you want to do some massaging of the data, you use Hadoop. Because Oracle becomes very expensive, you cannot distribute, you cannot do clustering, managing is a big headache, right? So Hadoop can be complementary. So any questions for you? Okay, let's get started on the So I think that was a brief. I covered a different perspective of the data. So now we really get into some hands-on. So this gives an overview of what we want to do with the weather data. So the weather data is available on NOAA website, National Oceanographic and Administration System. So we take the data, move it to STFS, we run some MapReduce jobs, we run some pig script, Hive, and we do Cassandra, we do Spark streaming, and the storm, the spelling mistake there, I think typo, suppose it's storm, and we take this Twitter feed. So the part going from the Twitter, part coming from the weather data that we massage in what we do there. Right. So this is where we're going to go. This is the data set that we took.
What's the objective that we are trying to achieve with this? I know it's a hands-on, but what's the overall flow that you're trying to see?
So you have a data on your local system. We put it in Hadoop, right? First, you want to do any Hadoop transaction, you have to move into Hadoop file system. Right? We move the data into Hadoop file system, then we apply some pig script. Pig script has some kind of logic. I want to know what the wind speed was there, what was the temperature was there, like greater than 45, greater than 50. So how do we do the filtering and show what things we can do with this pig scripting and what we can do, same thing with the Hive, how different it is. Right? So, and also you can see how the same thing can be fitted to Cassandra database. And we're going to talk about that, why Cassandra, why it's different, right? So then how we can do Spark analytics on data on Cassandra, and how we can do Spark streaming from Twitter and store it back into Cassandra, right? So this is one simple flow. This is not the end of it. We can have a Arduino sitting here bringing data into Cassandra or HDFS. There are many things. Probably it takes way too long, maybe 4 days if you want to do that. There are multiple solutions we can do. Suppose we can use the scoop here to put data here or into the HDFS, right? So there are multiple tools, but we chose this path because part of it shows a batch processing, part of it shows a real-time event processing from Twitter, and storing that data into the database. We can do ranking or accounting. We can do all that. So this is a kind of approach that we took: a static file and the live stream file, right?
Is there a particular parameter set you are focusing on when we are analyzing weather? It could be wind, air, rain.
Wind, temperature, air temperature. See, basically, you put your flat data into HDFS, then you run your queries on it. You run your filters on it to get some analytics out of it, right? So that we can show, right? So we go in a breadth, not deep. So what we can do, how we can plug in MapReduce or Java code or Pix code or Hive code, and all those things. This is the data set that we took. Okay, let's do some white coding quickly.
Can you go back to the previous slide?
Look at these slides.
Okay.
So MapReduce, right? See, we need to define it much more clearly. Is there any analogous example that you can give when you say MapReduce? You wrote history and everything, right? The wars, history, the politics, how they rule when British occupied India. What they did?
Divide, count and divide and
That's exactly what we're doing here. Right. So now, we all work the enterprise world, right? Right. So we have some data sitting in server 1, server 2, server 3. So your boss comes back and says, hey, can you write a program to get some data, aggregate data from here and here and here, right? And you run a program. You write your program here. So what are you doing? In typical we all follow. We wrote a program, you run it, you pull the data from here, you pull the data from here, and you pull the data from here. This traditional approach, right? So now, how about reversing it? You run a program here, it goes to the server, gets the data. Go to the server, get the data. Same thing that we all did. I think this was a standard method that we did all the time. So in MapReduce, you write a program, push the program here. Your code goes here. You push your code to the server where the data is sitting. You run it locally, and get the aggregates back to the column. That's MapReduce. Right? We push the code to the data. So you make it local to the program instead of getting the data. Why? Imagine the amount of network traffic you have. You have 10 GB file here, you have 30 GB, 50 GB file here. What would happen to your network? And how long it would take? And will it complete? We don't know. So what do? We push the program, push your code, write your Java file, push your code. Write locally, get the aggregates, get smaller data set, you come back and answer your questions. So So that's what we're trying to do here, right? Map reduce. That's the only step. There's no difference. So for that, we need to have some kind of framework, some kind of methodology. How do you do that? And Hadoop allows us to do that because of partitioning of your data, of block size partitioning of your data. So that's what we're going to do. So let's get on with it now. This is a typical example of map reduce. So we have the input. Here's 4 strings. What map reduce does, you tokenize the data, put a counter on each one, and reduce the counter. That's it. Class over. We're done. Map reduce, we're done. This is what is map reduce. So I'll have a 1 GB file, I'll give it to you, run your tokens, count them, you're done map reduce. Right. So it's not a big deal. It's just a methodology, and it's not new that we reinvented the wheel. It's just like now in a new pack. That's all it is. Any questions so far? Anyone?
Where do you apply it? You said, you apply it in your network or your infrastructure? What was it? You said it's a factor for what? When you go to the game, you go out there and you can track it.
Basically, we pushed your program to the server where the data is sitting.
You need someone on the server that has an agent or something?
Exactly. So that's the framework.
Okay.
That's framework. So you think of doing that, then you build a framework around it. So that's what Hadoop guys do. They split the data and they push the program over there, and the agent's running. They understand what you want to do. They do all that and bring it back to the column, right? So now what we did, we localize the data for the program that you wrote. So any questions here so far?
So what you're saying is, if someone initiated the program, the end result is whatever we are seeing on the right side that
Yeah.
exists on the local machine.
Yeah, that gets back to you, the column. Yeah. So this is the data sitting on each node, each server. Then you push the program which does this. It does tokenize and count each token, that program. So that continues to reduce it. It reduces it. See, number of occurrences of each color, they get reduced. The counter goes up. So when there's nothing to do, any more tokenization, that's the end of your result. So I'm done with. I counted all the words with the number of counters. So I reduced it.
Yeah, could you go back to the slide before that showed the 3 data sources and the laptop or whatever it was? No. Go next one. Well, anyway, I was trying to relate the outcome that you just showed us to the
Okay.
slide before that you showed us, which was essentially a laptop or a PC with 3 different arrows to 3 different data sources.
You wrote it on the board.
Pardon?
You wrote it on the board.
Well, okay, I'm sorry, it's gone then.
It's gone.
Okay,
No, I
then
can do
relate
it
it
again.
conceptually then
I can do
to
it.
that.
Yeah, that's not a problem.
Thank you. And how does Peter Piper relate to that?
Yeah, go ahead. Yeah,
That's it.
that's it. So this is a server 1, 2, 3, and this is a column. Maybe it's your desktop.
My question is, does the complete text of Peter Piper exist on 1, 2, and 3?
Yep. Those lines exist here.
Why is that reducing anything?
Why is reducing anything?
Yeah, I understand, what's the logic that says it's going to reduce it if I do this MR?
Go back to that.
Go back and reduce in 2 different steps.
Yeah, maybe everybody else understands it, I was just trying to relate.
You're
Yeah.
going to each, you're seeing the query to each
See,
instance.
if you
Right,
look
got
at,
that part.
if you
It's counting the number of occurrences
If
in
you
that
pick up-
system.
pay close
Summing those
attention to
together.
these numbers here. Every step, look at the numbers, the counters.
Now, he's trying to correlate it. Okay, so his
Oh, okay.
example was, if you write a program and run it on your desktop, all
Yeah.
your computation power is within that one particular computer. In this case, it's desktop, right? You're grabbing data from individual data source and computing within that particular desktop. In the Hadoop world, what he's saying is, write your program. The program itself runs on the individual nodes or clusters where not. So it's distributed. It's a distributed computer. It computes on the data where the data
I
is.
got that part. Wouldn't it accomplish the same thing if the text is already out there on 1, 2, and 3, just go to 1 and be done with it?
It's not the same thing.
Or it's different text?
Yes.
It
Oh,
could
yeah,
be
sorry, I
any
didn't
data
notice
could be
that.
any-
I thought it was a little poem I
that's
knew
a
as a
good point.
kid.
That's a good point. Let me see. Let me write here. Okay. These are the 4 lines.
Yeah.
1, 2, 3, 4. This is 50 GB file. This is 100 GB file. And this is a 200 GB file. Right? And maybe this is 300 GB file. Imagine your disk can hold maybe a maximum 500 GB.
Okay, I got it. Okay.
Now imagine I have to go to different nodes to process it. That looks, I can fit it in a text file, but that's just an example.
Okay.
Right? So you don't want to do map reduce on a 100K file. No, you don't want to do that.
Okay.
So Excel or Word will do it. You can number of words. Right?
Okay, thank you.
So okay. I think Hortonworks and MapR, they also talked about Hadoop infrastructure. They, at certain point, they touched on Page, Peak, Hive, MapReduce, Spark. It's no different. The only thing is the stack shows how they're arranged here, right? There's something called Ambari that I want to take you through. Zookeeper, they talked about. They talked about HDFS, Yarn, Page, MapReduce, Peak, Hive, Spark, and Storm. And basically, this shows how they fit in this whole puzzle, right? So what is Yarn, what it does, who's depend on Yarn, where the HDFS fits, where the Cassandra. Cassandra is not a part of HDFS or Hadoop. It is separate anymore. But in our VM, it's sitting with us. So we can tell how we can move data between Hadoop, Cassandra, HDFS, Yarn, how they can access, how the Storm talks to Cassandra, Spark talks to Cassandra. So if you take a standard VM from Hortonworks website, probably you don't get all these elements here. Storm, Spark, Cassandra, you don't get. Just pure HDFS, the examples. You run it, it works the same way. What we did here, we added more bells and whistles to this. We have Twitter coming in, we have Cassandra sitting together, and we make Cassandra, Storm, Spark, and HDFS talk to each other. So why we're doing that?
So the Hortonworks 2.1 version, so does it have all this framework or does it?
No.
It doesn't.
No. So we put this and created an image that you guys all install.
So Ambari is needed for the cluster management, or it's we can manage in some other field?
You can manage without Ambari. You have 2 nodes, 100 nodes. What do you do? They have to look the same because you need to manage them same. If I change a parameter, right now my IP address or domain name changed, a pattern changed, Ambari will take care of it across 100 or 1,000 nodes. You don't have to do it manually. It's an orchestration tool I'm going to talk about.
Okay.
Yeah.
So the other question is, if I just don't need Cassandra, let's say if I want to do with Mongo, right? So where is the mapping coming in to say, hey, my data sits in this HDFS, my database itself is going to be Mongo, right? So where do you map it after you put the data in HDFS, or at what point you overlap things?
Yes. Here, you see connector, right?
Right.
So there are connectors available. So we have to tie them. It's a job of tying things together, right? I have to write a code to integrate. It's an integration. So
right, but that's the programming part of it, the connectors come in. But what I'm saying is, when you have the data that's sitting in your HDFS, right? So is that the data the same as saying the data sitting in my database, or the data? We have 2 sets of data here. One is the data in the HDFS, and the other is the data in the Cassandra.
Yeah.
When someone says in the old world, oh, my data is sitting in Oracle, we understand that, right? So Oracle, you speak to Oracle, you grab the data, you speak to Oracle, you push the data in. Here, one of the first things you said was you pushing the data into HDFS directly in your previous slide,
Yeah,
right?
yeah.
So is that data then meant to be the data sitting under Cassandra, or is that data?
That's a good question. Okay. So what happens usually? Cassandra is for a quick read and write. Tomorrow we're going to talk about deep into Cassandra. Cassandra is a little different in what it does. It's a NoSQL database, and it has high write throughput and also very good read throughput. The Google Compute Engine we did, DataStack's a company called 100 million writes per second on Cassandra cluster. That's amazing. And that's when you use Cassandra for your transactional. Suppose you want a recommendation engine or data science. That's when you use Cassandra. But the large number of data sitting in HDFS, you push it up, you do calculations, you do algorithms run for like 2 days, you get aggregation. Where it goes, you store it in Cassandra so they can